Okay, so you guys are already familiar with your ions, your cation and your anion, right? And we've talked about how to name our polyatomic ion. It's chapters 12 and 6 and 12.
Okay, you got that one.
Everybody has 6 and 12.
Yes.
Okay, good. Okay, we're finishing up 6 and 12. We've gone over it. We've gone over most of it. Yeah. Great. You guys are rough today. Okay, so when it's called monoatomic ion, that's only when we're talking about a single ion, right? With a single letter, right? We're only talking about one element ion. Okay, so like if we're talking about the barium ion, right? So what is the charge on the barium ion?
You said it was +2?
Yes, it's +2. And so we know the charge on the bromide, right? So if you have Br minus, it's called what?
You're saying like it's an anion?
Well, we know it's an anion, but what would be the name of Br minus?
Is it bromide?
It's bromide, right? Because we put the IDE at the end of it, right? So what would be the formulas for potassium ions and fluoride ions?
So potassium would be K + 1.
Okay. And the fluoride would be
F -1? Or just minus?
so. We talked about transitional metals. The fact that with transitional metals, they're going to be changing. So we have to use Roman numerals. So I said transitional metals. Are there any other types of metals that we have to use Roman numerals for?
Yeah.
And can you tell me?
Post-transitional metals?
Post-transitional metals.
Metalloids acting as metals?
Metalloids acting as metals. And
aluminum? Was it aluminum? No, huh?
no, it's not aluminum. So we said transitional metals, post-transitional metals, and you said metalloids acting as metals. Anything else?
There's like some that are excluded, right? Like zinc.
There are special cases, yes.
Oh, I remember it. It's actinoid.
What was that?
Is it actinoid?
Yes, actinoids and
Anthinoids.
lactanoids.
Lacanoid. Oh, that's great.
Use your periodic table. That's what it's there for. Okay. Let's see.
What metalloids act like transitional metals? Transition metals?
All metalloids can act like transition metals.
But how do you know when they
It's
are?
where they're located with the non-metal, or where they're located in the equation, right? So if they're in the front, they're going to be acting like a metal. If they're in the back, they're going to be acting like a non-metal.
Wait, so if the metalloid is in the front, then we need the Roman numeral.
Then you're going to need the Roman numeral, yes. And then if the metalloid is in the back, then you just count to the noble gas. And then that's going to give you the negative charge it is.
Are you gonna give us the exceptions?
I will, just relax, relax.
Yeah.
I know, you're just like, give it to me now, I want it now. Okay, so we have special cases, right? So I've talked to you guys about mercury 1. Mercury 1 ion is always going to be a diatomic ion. It is the only diatomic ion that is known as a state. Okay, and so when we talk about mercury 1, it's going to be written as Hg2, 2+, where each mercury atom is going to be a +1 charge. Okay, so if we have manganese 2+, what will be the name of that ion? And don't everybody yell at me at once.
It's manganide or I'm sorry, Mn. I was looking at magnesium. It's yeah, is it manganide?
Nope.
No.
Nope. Manganese 2+. What would be the name of that ion? Manganese with the Roman numeral 2, right? Don't start making up brand new rules there.
I was saying the same thing. I thought you thought.
IDE means it's at the end of the compound. If you put an IDE on it, it's at the end of the compound. Is the metal ever going to be at the end of the compound?
No.
Okay, so then what must be the name for the ion for Mn3+?
3.
Roman numeral 3, that is correct. Manganese 3. Okay, what would be the formulas for nickel 2?
Nickel 2.
So what is the symbol? Ni2+. Okay, so at this point, you guys should be able to do this, right? Without me, spoon feeding, right? Okay, you need to make sure that you guys are able to do this because your practice exam is going to open up at 11:59 tonight. You will have an exam that's going to be due, not this Friday, but next Friday, right before spring break. I will be on a plane. I will be answering your phone calls or anything like that. I'm going somewhere. I may never come back. I'm going somewhere.
So that's great. That means we can all pass this.
No, that doesn't mean it. No. So make sure that you guys have a clear understanding of nomenclature. Nomenclature is a very important part of chemistry. It's a very important part of any type of science. You need to be able to name stuff and recognize names and recognize formulas. Because if you don't, you're going to poison somebody. We want to keep you guys from going to jail. Okay, that's our goal. Part of it, at least. Okay. Okay, so we have those polyatomic ions, right? So ammonium ion, you guys need to be familiar with. The hydroxide ion. The hydronium ion. You guys remember the chemical formula for the hydronium ion? Just in case you don't, I'll write it down for you. You guys are looking at me like this.
Wait, I said hydronium ion?
Hydronium ion. Let me spell it for you. Okay. So when you're making your ionic compounds, you want to go with the smallest formula unit. So that means that we want that ratio of your positive and your negative to balance out with that smallest possible number, right? So if we were talking about, let's say we had tungsten 4 plus and O2 minus bonding together. So what would be the chemical formula? And then you guys can give me the name. Okay, so somebody wrote, and I'll write down what they wrote. They wrote tungsten they put the number 2. I'm assuming that you get the Roman numeral 2. Would that be correct? First one.
No.
No, because the number that we have is 4, right? So we know it should be tungsten 4. Okay, what would be the chemical formula before we do this? The chemical formula.
W2O4.
W2O4.
I guess. I'm guessing.
Okay.
I'm cool. I'm positive W2, but the O4.
But are you sure it's going to be W2?
It's just gonna be W because the W equals a 4, and you assume that because of the Roman numeral.
That's right. It's going to be W, and then it's going to be O what?
O2 because 2 times 2 is -4. Well, the negatives, right? That
This,
balances out.
that is incorrect. The W2O4 is incorrect. W2 is correct because you want the lowest number that you could possibly get, right? What I just said, right?
Yeah.
Okay. So this guy would be called tungsten 4. And then, do I use Greek prefixes?
No.
No, I do not use Greek prefixes for ions. So there shouldn't be a tetra, di, tri, nothing like that. It should just be tungsten 4 what? Oxide. That's it. Because we know when it's oxide, we know the charge, right? When it's peroxide, we know that that's +1 now, right? But when it's oxide, we know that it's going to be a -2 charge. So it's always going to be a -2 charge if it's oxide, okay? And then we said tungsten 4 because that is that plus, that's the charge on the tungsten, okay? So the Roman numeral always represents what?
The charge.
The charge. Can you guys repeat that after me? Always represents. The Roman numeral always represents.
The charge.
The Roman numeral always represents.
The charge.
Okay. Now we're going to see if it sticks. Okay, so write the formulas for ammonium bromide and ammonium sulfide. Yolanda, I told you that I'm the stalker. You're not supposed to be the stalker. She said, I'll follow you to the plane with chemistry questions.
She doesn't get all the points. She moves the next one.
This question right
She doesn't have to fight it.
Is there somebody named Dr. Henry here? One of your students wants to know. Okay, so what do we got here? Give me some wisdom.
Okay, so ammonia is found on the polyatomic ions paper that you gave us.
Okay,
It is NH, the little 4, is it a subscript?
that's right.
Subscript 4 and then +1.
Okay.
And go to the periodic table, we get our S, and our S has a -2 charge.
Okay.
Then you have to cross them.
Okay,
And then, so because the NH is a polyatomic ion, and then the 4 just stays there. You can't switch over. So the 2 just like, you have to do the parentheses and then the 2.
that is correct. So we need the parentheses because it's a polyatomic ion. And we need to have 2 of those. That's it. Okay, what about ammonium bromide?
That one's just NH4 and then Br because they cancel each other out, right?
That's right. Good job. Good job, guys. And ladies. You guys did a good job, Kevin. Right. Yeah. Okay, so what, write the formulas for aluminum oxide and barium nitride. Where is? Jeremy.
Yes. Okay.
Okay, what do we got?
Oh, nice. I just want water.
Yeah, you can.
Okay.
Oh, yeah, there.
Okay.
And there will be some more that'll be going over there.
Okay. So do you want me to wear that or?
Just bring them back and then I'll send you back over one second. Okay, so we have aluminum 2 oxide. Is that correct? Aluminum 2 oxides. That's what I got as a suggested answer. So what do we know about aluminum? Let's look at the periodic table. So I'm showing you the answer there. Periodic table there. Okay, so where's aluminum at? Okay, so we know aluminum here. Now, even though aluminum is a post-transitional metal, it's always going to have the exact same charge all the time. Okay, so it's always going to be a +3 charge because it loses 1, 2, 3 electrons to be like neon. So aluminum is always going to be Al3. And since we know that it's always going to be Al3, aluminum is going to be one of those exceptions that we're going to be talking about. Okay, so that's right. It's going to be Al2O3. That is correct. Put that up on the board. So since we know that aluminum is going to be Al3, and then we have O2 minus. So then we're going to end up with Al2O3. Okay, because 3 times 2 is going to be 6. So if we have 3 oxygens, that's going to add up to 6, -6. And then you'll need 2 aluminums to add up to 0. So again, the charges have to add up to 0 at the end. Okay. You guys don't have to look so excited. Okay. So what about barium nitride? What's going to be the chemical formula for barium nitride?
This one's gonna be Ba, and being that Va is a +2 charge, you're gonna have 3 of those,
Okay, so
which would equal a 6+, right? And
Okay.
then nitride is nitrogen, so it would be N2 because nitride or nitrogen is a -3, and -3 times 2 is -6, and that balances out.
Okay. Okay. Questions? Concerns? Everybody gets it. Good. Okay, so when we talk about the name of the ionic compounds, we know that we have to use Roman numerals if they're transitional metals. Right, so for instance, if we have iron chloride, so this is actually would be iron 3 chloride, because we have to tell the charge of the transitional metal. Okay. Okay, so if you guys can do me a favor. Now, let me give you some exceptions. One of the exceptions is going to be silver. Silver is always going to be silver 1. So anytime that you have just silver, let's say silver nitride, right? Each one of the silvers there are going to be a +1 charge. Okay, so anytime that you see silver with something else, it's always going to be a +1. So it's like 99.9% of the time it's going to be +1. So if you just say silver chloride, so you know that it's just Ag0. If you say silver nitride, then you know it's Ag3 N. Okay. Another one is silver. Okay. The other one is cadmium. Now cadmium is always going to be a +1 as well, unless it says otherwise. So if you just hear cadmium oxide, you know that it's going to be +1. You don't have to put the Roman numeral because 99% of the time it's going to be a +1. The only time that it isn't is when I specify that it's something else. Okay, and that's also the same thing with silver. Zinc. Zinc is always going to be a +2. Why? It's always going to be a +3. And then we already talked about aluminum. Aluminum is always going to be a +3. Okay, so those are going to be your exceptions. And again, that's going to be always the case unless they specify a special case. So if they say zinc 4, then they're telling you that it's going to be +4. Okay? Questions? Does that answer your question earlier?
Yeah, but I got to the CAD.
Uh-huh.
Wait, let me see that. I thought it was a 2 plus. It's a 1
It's a 1
plus.
plus. Yeah, it's one of the exceptions. So cadmium is always going to be a 1 plus. Okay. Zinc is always going to be a 2 plus. Okay, so what would be the name of these compounds? Okay, do I have any? Oh, I have some names already. So the first one, Angel says it is lithium bromide. You guys agree or disagree? Everybody agree? Anybody disagree? Okay, good. Number 2. Magnesium iodide. Everybody agree? So why didn't I use a Roman numeral on either one of those? First one or the second?
Is there polyatomic ions?
They're not transitional metals.
Because they're not transitional metals, right? We know that lithium is a group 1 metal, right? It's an alkali metal. And it's always going to be +1. We know that magnesium is an alkaline metal or group 2 metal. It's always going to be a +2. So if we know that they're always going to be that, we don't have to use them. Okay. Okay. Yes.
It's not. You don't use diiodide, right? Because there's 2.
No, you do not use Greek prefixes with ionic compounds. Is this an ionic compound?
Yes.
It is. So do I use Greek prefixes with this?
No.
No. Okay. Okay. So we're supposed to be progressing, not regressive. We got to remember those rules, right? So when do you use Greek prefixes? I'm asking. Help me out here.
That's I don't.
When it's not an ionic, so give me an example when it's not an ionic compound.
Is it a covalent?
Covalent
Hormone?
bond. That's right. When it's a covalent bond, because either we have ionic bonds or we have covalent bonds, right? And there's one other time that we also use Greek prefixes. Oh, there we go. Somebody said it. Somebody said hydrates. We use them on hydrates, not on hydrogens, on hydrates. Okay. Okay, what about the next one? The silver, the Ag3N. I'm just gonna give you the name. Yes, we were. I actually said the name 6 times. Silver nitride. Okay, the last one. But that's all right. I'm gonna give you a whole bunch more. In a minute. And you guys, this is what we're gonna do. We're gonna play a game. Because, yeah. Last one. Any volunteers? Lord, are you missing anything? Where does manganese?
Roman numeral 2.
Okay, there we go. So it's magnesium. Manganese, manganese 2. All right. Okay. Questions? Concerns? I have a lot of concerns. Okay, so let's play a game because. Okay, so let's see who's on mine. So we're gonna do it like this. Okay, we're gonna compete. Yeah.
Can I ask you a question, Dr.
Yes.
Henry?
Yes.
Just give one more example. I know we're supposed to progress in whatever. I don't know how you said it, but covalent bonding. I know it's like sharing electrons. Can you just give me an example of a covalent bond?
Sure, I sure can.
Yeah. So what makes it a covalent bond?
You tell me what makes it a covalent bond. What is the
I
definition
know
of a
it's
covalent bond?
sharing electrons to complete. What is it?
They're sharing electrons. That's right. Where ionic bonds are doing what?
Taking away electrons from each other.
Yeah, they're going to either take away. One is taken away, and one is
Giving away.
taking and one is giving. Yes. Okay. So in the case of covalent bonds, they're sharing. Now, what do we know about covalent bonds? Is it going to be a metal and a non-metal, or is it going to be a metal and a metal, or is it going to be non-metals? That is correct. They all have to be non-metals. So isn't carbon and oxygen a non-metal?
Okay, I was a bit confused in that. So they have to be non-metals.
That is correct.
I didn't.
There are exceptions. There's always going to be exceptions because we know that in the case of boron, boron is a metalloid. Boron will form a covalent bond with fluorine and hydrogen. Okay, but boron will be an exception. Okay, another exception is beryllium. Okay, beryllium will form a covalent bond. Even though it's a metal, it thinks it's a non-metal. So those are your 2 exceptions. Did you guys get that?
No.
Okay, boron, which is a metalloid, will form covalent bonds. And beryllium, which is a metal, will also form covalent bonds. Okay, they are exceptions. So beryllium thinks it's a non-metal, even though it's a metal, but it thinks it's a non-metal. So it's gonna form covalent bonds. And the other thing about it, it also likes to have 4 electrons around it when it forms those covalent bonds. It doesn't reach its octet. So it's called what? When it doesn't reach 8 around it. Right, what's that?
Hypovalent.
Hypovalent, that's right. not hyper, hypo. Okay. So let's see. Who do we got? Who's our start with? Okay, we're gonna start with Alexis and remind me your name. Priscilla. Okay, Priscilla. Alexis and Priscilla. So Priscilla, you're gonna go on the board. Alexis, you're gonna go. Can you remember how to write on my screen, Alexis?
I think so, yeah.
Okay. So I'm gonna put either a chemical formula on the board or a chemical name, and it's gonna be the person still standing. We're gonna see who rules, the people online or the people here. Okay, hold on. Where's mine? Okay. And right over there. Okay, you guys ready? Come on, Priscilla, you gotta get over there. Come on now, come on. Okay, ready, Alex?
Yeah.
Okay. So your compound is the formula. Okay. Okay, Alexis, you can write on my screen. Well, one of you guys got to get it. Give you guys a little time. I'll give you guys a minute. Have a minute. Figure it out. More than a minute. Try something. Put something up there. Don't give up. Come on. I don't just try. We know that it's what's going on there. Is there metals there? You guys see metals? Do you guys see metals?
No.
They're non-metals. So what should I be using?
This is hard. I understand your pain.
It's a finish you get. Are you giving up? Yeah.
Can I like go down here? Oh. I'm gonna write it down here.
Yeah, you keep writing down.
Pretty well done.
No, he's saying he's really back me. I heard. Okay.
It says
Okay,
oh,
just in time too. Let's see. Dinitrogen, oxygen, tetrafluoride. Do you guys agree?
Yes.
That is correct. We use the Roman numerals to tell us how many of each of the elements that we have, right? We don't have to use mono if it's not in the last one. If it's the last element, you have to use mono. Okay.
yeah, that's what I was thinking about that. I was like, it wouldn't make sense to use mono there. I almost wrote it down too.
Okay, Angel. You're next on mine.
Would you use mono at the beginning or you don't have to either?
No, you don't have to use mono at the beginning. You don't use mono in the beginning. So online has one. Let me write this.
I've never typed on the board. Could I type it in the chat?
You can type it in the chat,
Okay.
but you can also write on the board. If you're
How do I do that?
so you want to go up top there'll be a little thing that says options. It'll say you're seeing Dr. Henry's screen or something like that. And then you click on that, it'll say options. You want to
Oh,
select.
request a remote control.
What was that?
Request remote control.
No, not request remote control. You're gonna request, it'll say options and it'll say annotate. Or when you hit the options button.
I'm a little technologically challenged, so I'm gonna try.
Okay. Okay. Yeah. Oh, that's you. Next. Yes, go up there. Come on.
That's the same one.
No, I haven't put it up there yet.
Yeah, I'm out.
Okay. All right, I'm gonna put it up there. I haven't put it up there yet. Relax.
All right. I'll just type it on the chat. I don't think I'm gonna figure this one out.
Okay, so you can type it in the chat. Okay, you guys ready? Okay, so here is the chemical formula. Yep. Yep. So by the way, online got 1 point. And let's make it worth something, right? We'll give 3 points to the team that wins, either online or face to face. Ready?
All right, there you go. I think that's it.
Are you sure?
80%.
Okay, that's incorrect.
Oh,
So you have a chance.
I'm missing the 2. I feel like that 2. I'm not. It's not a metal, so it's not a Roman numeral. But I'm forgetting. Do I have to put the? Do I have to put the dibismuth?
Oh, you're telling me bismuth is not a metal?
Wait.
Sure.
No, it is a metal. It's
Okay.
a post-transition metal. So the Roman numeral 2 would be in the middle.
Are you sure?
Post-transition metal, does that mean it counts as a metal?
Now, what did I say? I had you guys repeat it 3 times.
Oh, it's only for
What was it?
non-metal.
Say it again. Say it again. Say it loud so they can hear, because they can't hear anything. You gotta say it louder than that. Yeah, exactly. That's how I want you to say it. That is incorrect.
Really?
Yes. Well, tell them what. Tell them what. You said the Roman numeral always represents what? The charge. The Roman numeral always represents the charge. Okay. And do you use? Is this an ionic compound or is this a covalent compound?
Ionic. So you don't use Greek prefixes.
Oh, we don't use Greek prefixes. Oh, is that the right charge?
Yes.
No.
No.
What is?
They say it's 6.
What is PO3? Somebody says it's phosphite. Oh, that is correct. Alex got it over here, but they don't get the points. The correct answer is, well, she doesn't get the points either. They didn't get the points. It is 6. Yes, the Roman numeral will be 6. Why is the Roman numeral 6?
Because you times the 3 to 2.
It would be like that.
Yes, because we have 2 of them. We have 2 phosphites, right?
Okay.
Yes. And remember, it always has to add up to 0, right? And we only have 1 bismuth. Okay, you guys ready? Okay, so we have 1, 0 so far. Online is winning by 1. Okay.
1.5. Come on.
1.5. Okay. The next person is Anthony. Anthony, you ready? Are you ready, Anthony? Give me some acknowledgement. Okay. Well, it looks like you may already have a win if Anthony doesn't respond. Anthony, you responding?
Yes.
Okay, well, we'll move on to the next one. Ariana, you're gonna take the lead for Anthony.
That's the point.
Are you ready? Acknowledgement? Okay, okay. So,
I get a point for whatever happens, and then another point for it.
okay, yes, that's fine. Okay, so here is your, let's see. Here's your compound. Ammonium persulfate.
Yeah, you.
Ian, coach.
It's going well. I know you're not asking Siri.
No.
Okay, so Ariana, that is incorrect. Are you settling for your final answer?
We're still working here.
Oh, there's more, hold on. I like it because I can see their answers. So Alexis, that would be correct. We're gonna see if they get it. So since it was a head-to-head.
We're working on it.
Okay, you got 1 minute to finish up. That is incorrect. Okay, so let me give you guys the correct answer. So ammonium, just talked about. Okay. Persulfate. We know that sulfate is SO4. It's on our polyatomic ion table. It has a -2 charge. We have ammonium has a +1. So we're gonna need, for persulfate, we need to go up 1. So it's SO5. 2 minus, right? So I'm gonna need 2 of these to balance it out. So it's gonna be, my answer is gonna be N, N, H, or parentheses 2 SO5. Okay? Because when we use per, it's the same thing as hyper. That means you're going to add an additional oxygen. Okay?
Another 0.5.
Another 0.5. No, it's all or nothing, man. It's no point, no half points there.
You're not consulting me, man.
They're not consulting you, right? You guys are. They're definitely consulting over here. Although it
I
has,
know.
yeah.
It's like,
it
like
hasn't
the whole
helped us
class
yet.
versus segments.
Okay, you guys ready for the next one? Okay, here's our next one. See if you guys remember. That's what I'm supposed to do. That's the purpose of this. Okay, so let's do. Yeah. Okay, that would be. Oh, I think that's yours.
That's why I said.
Yes, got this, bro.
Here, did I use the markers? Oh, and it's online. This would be Linda Can't. I believe it's Carol. So what type of the
Who's up next?
Oh,
I can't see what they write. What's that?
Only for a split second.
Oh. Wow. Great.
oh no, my bad. Let me erase that. That's not it.
That's your final answer, Carol.
I don't even know this.
Are you checking out the chat? I need the final answer for Carol for it to come out. And you notice, you know you guys can tap to each other, right?
The H2O.
You know, where it says everybody, you can select the person that you want to chat with. You like right?
Bro,
You get. Oh, I'll answer.
No,
Okay, there we go.
cheating.
There we go. Okay.
So Carol has to type it out or say it.
Put it times, put it times.
That is incorrect. Are you, wait, is that your final answer?
No, say no.
That's good. Let's just, I already told you that it's.
I've reached the room.
Okay, so Carol has correct answer. I'll type it up for you guys.
Wait, what did you say? You got it?
I said Carol has the, oh wait, are you forgetting something? There's one part that she's got most of it, my bad. She hasn't finished. She has more type. Yeah, so you have a chance.
And then keep that,
Gotta finish it up, Carol. What was that last part? Got the first part.
Okay, give me a minute.
Okay. Well, you better hurry because she's getting close, though. Well, you're closer. You're closer.
Did you
Okay,
get my message, Carol? There you go.
there we go.
Yes, thank you.
Sorry. It's hyponitrite. IT. Yeah. Hypo because NO3 is nitrate. NO2 is nitrite. NO would be hyponitrite.
right there, don't worry, yeah.
2.5.
You're not getting that 0.5. Keep trying.
It works in my head. Okay.
It's 2-2-0. Come on, face to face.
Someone bought you, huh?
What was that?
Someone bought you off.
Somebody bought me off.
Just kidding.
That's why I'm not giving you that 0.5.
Yeah.
Hey, my dad's off.
And they're still losing.
My dad's off.
Well, you guys are not paying enough, obviously. Okay, are you guys ready for the next one?
Making it interesting.
Okay.
He just say make it interesting.
No, because he's like, they're still losing. He's making it interesting. He doesn't want to give it away. You know?
All right, I see how it is.
He's going to put the 3 in front of the 2.
He's like, damn, it's still my chair.
Okay, so your next one is, I'm gonna give it a chemical name, and then you guys have to give it a chemical formula. Okay, you guys ready? I need the chemical formula. Dihydrogen tetraiodide.
Who's next? Got it. What'd you get?
Okay, let's see what we have here. Oh,
Yeah.
okay, Mitzi.
Yes.
Okay, so you said H2I4.
Oh, tiebreaker.
Okay, you guys are tied.
We got one.
Do another one. Do another one.
Okay,
Same people.
okay. Okay, Mitzi and what's your name again? Christina. Okay, Mitzi and Christina, we're gonna go for a tiebreaker, right? It'll be a question.
Jeopardy.
The Roman numeral, so you gotta answer, represents the what? The chart.
Damn it. That was
Wow.
Okay, you guys, okay. One more time. Okay, so I'll give you a hard one.
all right. You never know.
Let's see.
Hopefully. Hey, y'all better help, man.
This will be a hard one. This will be a hard one because we haven't recovered, right? We haven't recovered. So when we're talking about acids,
Oh, Lord.
when we're talking about acids, what are the
Said assets.
acids? What are the key features that lets us know it is an acid?
Aqueous.
Aqueous? Oh,
Plus. The addition of hydrogen and the
what was it? Did you guys say hydrogen and aqueous?
I don't think they did.
Yeah.
They said hydrogen.
Yeah, we all said it.
I think we did.
The three of us right here.
She's very quiet. So we had to take over.
Oh, you guys have to take over. But it's her
Yeah,
question.
but she said
Oh,
it.
we
Where
said
you said
it.
She said it. She said it. You had to
One
repeat
team,
it
one
for me.
fight.
Ask her the question.
Okay.
She said it. Didn't you say it? She didn't hear you. See?
It's because I didn't hear you. Okay.
Yeah.
So what we'll do is we'll move on to the next one. So we'll call
Okay.
that as a tie. I'll give you both one.
Yes.
Double
Okay,
nothing.
so
Let's go.
Yeah.
Now she said
Good stuff, good stuff.
Let's go.
okay.
This is how it begins, huh? All right.
Yeah, that's right.
Finally, the money's working.
Okay, so we got 3-1. Okay, so you guys ready for the next one, right?
Let's go. Show what's up. Show what's up.
Watch when you're over there.
Dude, I want you guys not to answer me. I'll write it down real quick. What's, I don't care what happens.
I can see yellow.
It's yellow.
That was yellow?
Yeah, could be black.
So much fun.
Then I.
Okay, that is your name.
Oh, oh, my God. Wait, no, I lied.
Stop, I'm already done.
Did you mean to write?
That's it.
Mean to?
Plutonium.
Platinum,
Plutonium.
so that's different.
Plutonium.
That one. You're acting like we know the. No.
Like you know the periodic table.
Yeah.
It's, I'm acting like you have a periodic table in front of you. God forbid.
Everything back.
We all have one here.
Oh,
All right, I got the answer. Do I type it in or is it just them?
it's gonna be dulce.
Hold on.
Dulce is gonna be the online competitor. Are you there?
Who's this dude that gets so
I got you. I'm gonna send it to you.
Okay, give me an answer. Give me an answer, Dulce.
Oh.
We
Wait,
can
there is the answer?
just spray whatever in the audience. It's like, oh, she's tired of the chairs.
We had a lot of cocktails that day. There were a lot of cocktails that happened on cocktail hour.
Yeah.
Wait,
yeah,
where's the
yes.
difference?
Yeah.
And I'll say, the only people that showed up to
Yeah, right
cocktail
there.
hour were
We got it.
the people that were online, so.
Go, come on.
Yeah, oh, help us, yeah.
Oh, wait, it's not cheating. Come on, cheat.
Oh,
You ain't
yeah.
cheating.
Nope.
Jokes on her.
They're showing me their skills.
Yeah, she's our skill. Yeah, you gotta eat.
Wait, which one is it now?
It's the one underneath.
Oh, just in case she's not there.
Let's see.
What? Wait a minute.
No, she's here.
She's here, dude.
Dulce.
And that's a negative point. Or negative 0.5 point.
I send you the answer, Dulce.
Is it wrong?
Oh, they are serious over there. I sent you the answer.
He's got a team on his back, man.
Well, there's a lesson to be learned. He showed up on cocktail hour.
Well,
Yeah, we showed up, all right.
I know what I was
So that's what comes to cocktail hour. You want
What
cocktail?
happens every week?
Not that well.
Okay, so we have it here. We have an answer here. Let's check it out. So this is the answer that they have.
Emoji.
Okay, that is the correct answer. So because I got it before you guys did. And I'm not just saying that. Okay, so it's 3-2.
3.5, man. 3.5.
What?
Okay, so let me tell you who's going next. Itzel and Dim. Okay, you guys ready?
Let's go, Big D.
Clear.
So what's up, homie?
Okay, I'm gonna give you guys the chemical formula, and you guys are gonna give me the name. Or actually, I'm gonna give you guys the name. You guys can do the chemical formula. Okay, you guys ready?
Oh my God. You could, you really could. Oh my God.
Dichromius acid.
Oh, hold up. Bro. Damn, she says she's not gonna go fast. Right. Go fast. But then you should also then.
Package, yeah, ready to go.
What?
All I need to be afraid of her.
All right, I got the answer. Should I type it in?
No, it's Itzel, not you. You
Oh, I
can't.
didn't hear that part. My bad.
Yeah, Itzel has to answer. Itzel Chavez, are you there? If not Itzel, then it's Joyce, that would be after.
Knock him off that team. Yeah, you should be his own team. He's so.
Okay, Itzel says it is.
No way.
Are you sure?
That's not it. Bet money on it. Bet money on it. Bet money on it.
You guys, I'll give you guys an opportunity to discuss there.
Come on, Demi.
I'll ask this. Dichromeous acid. Dichromeous acid. I ate organic apples despite them being poisonous.
You gave us that.
Demi, like, it's a frog. Would be a frog.
Wait, Rome. Oh, that's why.
Are you guys discussing it online? Dichromeous. Yes. OUS. I'll do a reminder after we get this answer. You were closer with the first one. That's my hint. Wouldn't that be chromius? Is that dichromius? That's right. But we have dichromius.
Me too.
Look at the root. Look, because in both cases, I'll tell you both. I'll give you guys the both. That is closer. Yes, closer. You're looking for, it says dichrome. So do you have anything that says dichrome on your polyatomic ion table? Dichrome. Yes.
Yeah, we do.
So we have dichromate, right?
Yeah.
Okay. So I'm gonna give you guys both a mark. Neither of you guys got it. The answer,
Isn't it 6?
it should be 6, right?
Yeah,
So it should be
my bad.
2 CR2 O6. OUS, because you're right when you said the IT part, you dropped down by 1. That part you were correct by. So when it's OUS, that means that you have
The answers go.
ITE, right? And since it's OUS, you have ITE. So anytime you have an ITE, you're going to replace it with an OUS. And then in this case, the root of it was chrome. So it's chromite. So chromate is, chemical formula for chromate was CR2O7. That's chromate, right? 2 minus, that would be dichromate. So dichromite would be 1 oxygen less. So if we drop down by 1 oxygen, that's CR2O6. And then we need those 2 hydrogens to balance out the negative charge. Yeah, you missed the acid parts. We talked about it. Oh, we talked about it in class. It'll be towards the very end, last night, last night.
Oh, okay.
So don't worry, we'll do a brush up on it. Okay, so this will be our 50-50, our 50-50 point. So we're gonna go over some more stuff. I just want you guys to get motivated to get ready to finish it off, right? Then we'll do the second half of the competition. So far, it looks like online is ahead, 3-2.
Okay.
3-2.
Underdogs, bro.
Okay, online is ahead by 3-2. We're gonna take a potty break, and then we're gonna go over some more stuff, finish up this chapter, and then we're gonna finish the competition. For points. So I'll see you guys here in a few minutes after the potty break.
Jocelyn, so
What was that? What was the question?
she wants to know why it's the Apple thing.
Why is it? Can you repeat that one more time?
Yeah, like when you go to IT to OUS, she's asking why is that?
Okay, let me go to the board. It's easier for me to write. Hold on, give me 1 second. I'll show you.
I didn't even double look at it.
Okay, so chromate is Cr2O7 2 minus. Chromite is 1 oxygen less. So if it was per dichromate, then we have 1 extra oxygen. Okay, if it's if we're 1 below the chromite, we call that hypo chromite. That would be Cr2O5 2 minus. Okay, now when we're talking about an acid, we use this term, I8 organic apples, light, and being poisons. Okay, when it's ite, we're going to change it to OUS and put acid at the end. When it's 8, we're going to change it to IC. So for the acids, this guy would be called per dichromic acid. The formula for that would be H2 Cr2O8. For dichromate, it's going to be dichromic acid. And the chemical formula for that is going to be H2O7. since this is IT, we're gonna call this guy dichromous acid. And that's gonna be H2Cr2O6. So then hypodichromite is going to be hypodichromous acid. And that's going to be H2Cr2O5. Okay, so when you're dropping an oxygen, you go from H to I, and then I to hypodichromite. In this case, we go from high S. Okay. Does that help? Yes or no? Yes. Okay, good. Thank you. Oh, and then let me see. My ride has hydraulics. This guy is called sulfide. So when it forms the acid, you put an H, you want to balance out the H's with the hydrogens. I mean, you want to balance out the charges with the hydrogens. And then you put a Q. This guy will be called hydrofluoric acid. So in other words, we're adding K, although in this case we use the whole sulfur part, hydrosulfuric acid. So my ride IE has hydro drums. So these guys are going to replace the IE. Okay, so if I have HCl, you know, AQ, this guy's going to be called hydrochloric acid. Okay. Get that down. So yeah, this pertains only to your acids. No worries. Okay. Are you guys ready to start back up? Some of the guys all out in the hall.
Yeah, already.
That's the point.
No.
Yes.
Okay, you gotta make it that short.
So. Well, yeah. So did I, because I need to make some adjustments.
Okay, that's how I put that up.
Okay. Ready, Freddie? Okay, you guys are ready. Let's go. So we're gonna add on, we're gonna do more lecture and then we'll finish up. Okay. It's just called nomenclature. And so this pertains to acids. Marcos. And again, this is IUPAC nomenclature. Exactly. They asked me a question, I answered the question.
Oh my God, that's some important information.
I'm like, you could have said after break.
I'm stuck. Okay, so we talked about the hydronium ion. So the hydronium ion is actually used to dictate the acid. The only thing is that for simplicity, we often will just draw the hydronium ion as the hydrogen ion. Show you that. So H3 plus is just going to be H plus Ag. So these guys are comparable to each other. They're the same. Because what happens is that the H plus that's going to be moved from the acid, it's going to bind onto water. It's going to be very clingy. Have you guys had a clingy relationship before?
Yes.
Okay. So H plus is that clingy relationship. So it just binds onto the water. It's like, I love you, I love you, I love you. Can't go anywhere without me. So these are 5 acids. Carbon-based acids are going to be weak acids. So anything that has carbon in terms of acids, they're going to be weak acids. All the other ones, when they end with ic, they're going to be strong acids. Except for hydrofluoric acid. We'll talk about that a little bit later. That's considered to be a weak acid. So when you're writing the formula, you're going to use that H plus to balance out the negative charge of your oxy and ion. oxyanion or your anion in general. So for instance, if I have P minus, P3 minus. So if I'm talking about the acid, I'm just gonna write it as H3P. And I'm gonna put AQ because acids are only gonna occur in the aqueous state, meaning that it has to be in water, okay? So, and this acid would be called hydrophosphoric acid. Okay, so we have the hydro and the ic. This guy here, negative, the P -3, we know that that is called phosphide. So basically, we added our OR and then IC. So an acid afterwards, and that's going to make it phosphoric, hydrophosphoric acid. Okay.
Because we added the hydrogen becomes an acid,
That's right.
and then hydro because what?
The hydro, because there's no oxygens here. So we always have, anytime that there's no oxygens, we have to use that hydro for it, right? And you're only going to use that in the case of your root is going to be a IVE, right? So if we think of it, my ride IVE has hydraulics. That's written on the side of your polyatomic ion table, so that help you guys remember. Okay. Okay, we've already talked about when you're in the same group, you're going to behave similarly. Okay. So group 5 is going to behave similar to each other. So your sulfur, your selenium, your telluride, they're all going to behave similar to each other. So given that the name of H2SO3 is sulfurous acid, what is the name of H2TeO3? So aren't Te and sulfur in the same, tellurium and sulfur in the same group?
Yeah, so it'd be would it be tellurious acid?
It would be tellurious. Okay, the second part, given that the formula of perchloric acid is HClO4, what is the formula for perbromic acid?
It'd be HBrO4.
HBrO4. That is correct. We all-
AQ?
AQ, yes. That's me. Okay,
Beautiful.
questions?
I do. So the sulfurous is an exception, or can you explain that one more time? As to why it's not ick again? I know you have the rule on the paper, but in terms of like where it's at in the
So if we have the root, we have SO3, 2 minus. That's called what?
sulfite, I got it.
Called
That's why.
sulfite. So since it had ends with IgE, that's what the SO3. It lets us know that this guy is the sulfite root. So then we're going to replace that IgE with OUS, but acid. Okay.
Gotcha. Okay.
If it was sulfate, then it would be ick.
I'm sure my
So if it's SO4, 2 minus, that's called what? What's that called? Okay. SO4, 2 minus. Polyatomic ion table. What is it? Sulfate. So this guy is sulfate, right? So if we make it an acid, so by putting H2 to balance out the -2 charge, SO4, AQ, we know that that guy is going to be called sulfuric acid. So generally, you put IC when it's ATE, and you put OUS when it's ITE. Did you guys get that? And that's why in that little, I ate organic apples despite them being poisonous. 8 ATE, IC. Okay. And again, this only pertains to acids. Okay. Okay, so here, this just shows you that concept of the prefixes, right? Per means that we added 1 additional oxygen from that chlorine. You have 1 fewer, that OUS. You have 2 fewer, hypo-OUS. And if there's no oxygens, we use hydro. Okay, what is the name of H2SO3? And let's assume there's an AQ at the end of it. We have some answers. We got sulfurious acid. Sulfurious acid. Okay. What is the formula for tellurious acid? I can get there. Okay. So we've already talked about the oxyanic ions. Those are your polyatomic ions. You want to be familiar with them. So you want to be able to use that table. Okay. So this is the case where they're showing you the acid and they're showing you the ion, right? So they give you the acid suffix and the anion suffix. IC for 8. 8. We also have that per, which is a prefix. OUS for ite. Hypo OUS when you're down by 2. Ite. Okay, and then hydroic when there's an I. Okay, questions? So what is the name of this polyatomic ion? No. Since it's a polyatomic ion, it has a special name. Do you have your polyatomic ion table?
Is it nitrous acid?
No, what is the name of the polyatomic ion in
Oh,
O2 minus? Before we get to
nitrite.
nitrite. Call this the nitrite ion. That's right. Nitrite. So since it's nitrite, what would be the acid that would be made from this ion? So the chemical formula would be H. Nitrous. Yes.
The IC sounded right.
Since it ends with ITE, we put OUS, right? What do we call this guy? Nitrous acid. Kimmy and Jeremy, you guys got it?
Yes, sir.
Okay, we're gonna find out. Remember, you're up next here.
I know.
Okay, write the formula for hypoiodite ion. Hypoiodite.
Wouldn't it be IO2 negative?
Are you sure?
It's just IO.
It's IO negative. Yes.
Oh,
Okay. So
Yes.
it's normally for iodate, ATE, that's IO3 negative. If it's iodite, that's going to be IO2 negative. And then IO negative will be hypoiodite. 8. Height. And then you have hypo. Okay. So what would be the acid for our hypoiodite? Chemical formula would be HIO. What would be the name of that acid?
Hypoiodius. Acid.
Hypoiodius acid. What about HI?
hypoiodic.
Is it hypo?
Oh, I'm sorry, not hypo.
It's hydro.
Hydro, that's right. Hydro. Iodoic acid. Okay, questions? Concerns? So did everybody get that down? Oh, did you guys eat it back? Okay, everybody got it?
Or this is tough. Be honest, this is tough.
Okay. Okay, so this is just a summary, and it just kind of tells you how we get to each of those acids, right? The acid and the anion. That's the anion. Okay. Okay, so now that you know everything, write the name. Write the name of magnesium. Oh, sorry.
Magnesium, go ahead. Magnesium.
Never mind. Write the name of MG parentheses BrO4 parentheses 2. Said magnesium perbromate. That's right. Magnesium perbromate. Not because of the 2. It's because of the 4. Because normally bromate is 3. It's O3. Okay. What about the next one? Potassium selenite. What? It is a rock. Making a deal with the devil.
Yeah. I'm making sure that
So potassium is K, right?
That is correct.
And then you have Se, and then you got to look at the group that you have in common, right? So you would look like at sulfur.
Okay.
And sulfite is SO3, but you would replace it with SeO3.
Okay. Correct. Oh, then you put 2 there. That's right.
Oh yeah, you need to balance it out.
That's right. Job. Okay. Everybody get it?
No.
No?
Potassium 2.
It's potassium.
Right.
Selenite. So selenium is in what group?
Group 5.
4. How do you guess?
16.
There you go. What group? 16. Okay. Who else is in group 16 that is on our polyatomic ion table? S. Okay. So what is
Oh,
so
it's 2 minus. That's like if you have a 2.
that's right. Yes. Because it's going to be like the person that's in the same group, the family member that's in the same. Okay, so if you look at, you said sulfur, right? Do me a favor and look up sulfite, IT, sulfite.
Looked at it here. Wait, sulfite? Found it.
Okay, what is the chemical formula?
SO3. Oh, ITE?
ITE,
Means there's an
right?
O next to it and a 3.
That's right. So when we have an ITE,
Copy,
That's
copy,
the two.
copy.
For the 2 minutes, the 2.
yes, it's SO3 2 minus, right? SO3 2 minus. Okay, now sulfite, right, is in the same group as selenium, right? Sulfur and selenium are in the same group. So since they're in the same group, they're going to behave similarly. So that basically means selenite is going to be the same way as sulfite. So this guy is going to be SeO3 minus. Okay, because they're in the same group. So remember when I told you, day one, groups are going to behave very similar to each other. This is one of those references that I was making reference to. I know it's getting late. See your eyes. Okay, you guys ready for the next part?
Late would be laic.
Okay. So when we talk about an acid can be there's a term called polyprotic. Protic basically means proton, right? That H plus is just going to be a proton that's being added. So if we lose one H plus, this guy goes from H3 PO4 to H2 PO4, and it's going to be a minus. So the way that we name this, we go back and we start using dihydrogen. So we use those Greek prefixes to sit there and do that. Okay. So we start off with phosphoric acid, then we get dihydrogen phosphate ion because it's an ion. It has a negative charge associated with it. If we lose two H pluses, then it's going to be hydrogen phosphate ion. You have this on your paper, right? You have both of those on your paper. Now, sometimes you'll see it referred to as bi. So you'll see biphosphate. Biphosphate is the same thing as hydrogen. Phosphate. Okay. When I talk about bicarbonate, that's the same thing as saying hydrogen carbonate. These are ions because they still have charges associated. Okay. So these guys are equal to each other. They're the same thing. Okay, so bicarbonate is a common name. Biphosphate is a common name. So hydrogen plus there. So if I have hydrogen sulfate, what would be the common name?
Bisulfate.
If I have hydrogen sulfate ion, what would be the common name for that?
Bisulfate.
Bisulfate. Okay. Okay, so this is just giving you all the things that I just talked to you guys about. We're not done yet. Okay, so this is basically how you use it. It's gonna be the exact same way. The only thing you're using a polyatomic ion, and if you're using a transitional metal, you still have to use the Roman numeral, right? So in this case, if you have Fe parentheses HCO3 parentheses 3, we're going to call this iron 3 hydrogen carbonate. Or you can call it iron 3 bicarbonate. But if we're using IUPAC nomenclature uses this form. If we just say, give me the name, then you can go either way. Common name or IUPAC. So what will be the formula for ammonium hydrogen phosphate? Can you guys hear me?
Yes.
Okay.
So whenever you have a name like this,
Mhm.
you always write the formula the way it's given to you. You never rearrange anything.
No. Well, you're not going to rearrange anyway, but you always going to put the metal in front. Metal always goes in front. Right.
Gotcha.
Okay. Or the cation goes in front. Okay. So in this case, we have the cation. It's not a metal, right? So what is the chemical formula for ammonium?
It's NH4.
NH4 plus, and then what is the formula for hydrogen phosphate?
It would be H, right? And then PO4.
Okay, HPO4. What charge is associated with that?
3 minus.
Sure.
Phosphate.
Yes, it's hydrogen phosphate. So it's going to be 2 minus.
Whoa.
HPO4 2 minus. Yeah.
Okay, so then how many of those are you going to need? How many?
You need 2. You need to multiply it by 2.
Okay, so we're going to need 2 of those. Okay. Questions? So the question is why 2 minus again? It's 2 minus because originally phosphate actually starts off with 3 minus. If we add an H plus to it, it's going to remove one of those minuses. Okay. Okay, so we've talked about hydrates. Hydrates is just that addition of waters. And so we know it's real simple. All you have to do is name the compound, and then we're going to name we're going to use the Greek prefixes to tell me how many waters we have. So what is the Greek prefix for 5?
Penta.
Penta. Okay, so this guy would be called this one over here.
Pentahydrate. Oh, you're saying the whole thing?
Mm-hmm. So I said copper. 2. Sulfate. Hydrate. Okay, questions? The charge, Roman numeral is the charge on the copper. So we know that this is going to be a +2 charge because we have sulfate. What's the charge on the sulfate? It's going to be -2. -2.
Oh,
So,
they're getting the same?
because you only have 1 copper, right? How many coppers are there? 1. So that has to balance out the charge. So always remember the charges have to balance out.
Dr. Henry, just to double check, the explanation you gave us with phosphoric acid going to dihydrogen, going to hydrogen, the polyatomic ion table does that for us, or it shows that, right? You're just explaining why that is?
Yes.
Okay.
Yes. Your polyatomic ion table does a lot for you, but I've been trying to explain so that you guys will learn how to do it, and when you're not so reliant on your polyatomic ion table. The goal is to get you so that you know where you're going, right? And you don't need it all the time. Okay, so how many water molecules are associated with each formula unit of anhydrous sodium carbonate in Na2CO3 .10 H2O? That is correct, 10. Okay, now name the hydrate. Full name. And somebody or a point, either online or face to face, tell me what does anhydrous mean. That's right. Okay, that's a point to face. So now we're 3-3.
Oh, good looks, good looks.
I remember it because I broke the crystal during the hydrates lab, so I remember all of that.
Oh.
Yeah.
That's not my girl. Is there a cookie?
No, because I broke it. I felt really bad.
So we're at 3-3.
Sodium carbonate.
Okay, so you said it's sodium carbonate. Okay, so write the formula for a nickel 2 chloride hexahydrate. Okay. So we have 6H2O at the end. Ni Cl2. How did you get that 2? So then you're telling me that the Roman numeral represents what? Jerry? The Roman numeral represents what, Jerry?
Charge.
Oh, wait, I do know that. Hey, come on,
You gotta
Jerry.
do something because you said it 4 times. We're paying attention.
Yeah.
Ah.
Always surface charge.
That's right. Okay, so the last thing that I want to talk about before we finish our competition, that's metallic bonds. So metallic bonds are just the bonds between metals. So what happens in the case of metallic bonds? What happens in the case of metallic bonds is that the metal will actually drop the electron kind of next to it, right? And so what you get is your electron delocalized. So you're going to end up with a sea of electrons. So you're going to get your metal, which is going to act like it's a plus charge, and then you're going to have electrons. You're going to have a metal and an electron, and a metal and an electron. So it's going to look something like this. Okay. So you see your metal, which is going to act like it's a plus, an electron, metal, electron, metal, electron. And so this is what's going to hold it together. So metallic bonds do it that way. So we can actually make alloys as a result of that. So if we melt a metal, two metals together and mix them, we can make alloys. So how many of you guys have rose gold? Rose gold, not on you, yeah. So rose gold is an example of copper and gold. So that gives it that rose color. How many of you guys have white gold? Okay, we know who's bling here. We know who got a real job here. You know, so, yeah.
Those are gifts.
Those are gifts, okay. Oh, they got sugar daddies.
No, those were from my, from when I turned 18, they gave me.
Ah, you can see it.
Yeah, I asked for rose gold and white gold now.
I don't do gold.
I don't like regular gold, I know.
Please.
I don't like regular gold. I take silver.
Yeah, sure. Stand by it.
No, she didn't. Okay, sorry.
Guys, I'm gonna give you a really quick announcement. Rupita and I were gonna offer like turn hours during Tuesday and Thursday. I'm gonna do them on Tuesday and she's gonna do it Thursday. I don't know what hours she's gonna offer. I think I will have to ask her probably next week. But for you guys, which hours like will be better for you during Tuesday? You guys can. In the morning.
What time are you available?
Is that at night?
That's the real question.
In the evening.
On Tuesday, I got class.
Yeah. Like,
Yeah, we the same class.
8 in the morning?
And even in Zoom would be cool too.
Yeah, I will offer it to Zoom.
Like if you do like the morning for Zoom, that'd be cool. If not, you can do it too.
Nine, like 4 to
10,
6.
cool. 9,
4 to
9:30,
6.
10.
That works pretty much.
11, yes, 11.
You looking nice.
Okay, how about this? We'll send you guys a survey, you guys answer the survey,
Yes.
and then, okay.
Okay.
One thing.
We'll be in the, guys, we'll be in the morning and then I'm gonna.
First, mornings or evenings?
Morning.
Okay, those who think morning, raise your hand.
Either way, Rupert is gonna offer turn hours on Thursday, so like. it's-
Yeah, there'll be a link for them.
Yeah.
Yeah, go ahead. take
Yeah,
it.
on campus, on app.
And
The campus.
You're not gonna worry about it.
But the ones who can make it on Tuesday, what hours would it be like better for you guys?
On Tuesday, it's wide open.
After 12. 12 to 2. After 12.
After 12,
Okay,
4 to 6.
12 to 2?
okay.
Sorry, 1 to 12 to 2.
Okay. So these are examples of some alloys, some of the common alloys that you come across. So we have 18 karat gold. 18 karat gold is 75% gold, and 12.5% silver, and 12.5% copper. Bronze. It's not at the back.
Like almost the last. Yeah.
Oh, we have bronze. Bronze is going to be 60 to 95% copper, 5 to 95, 5 to 40% zinc. Sorry, that was brass, not bronze. Bronze is 90% copper, 10% tin. Carbonated steel or carbon steel is 99% iron and 0.2 to 1.5% carbon. Pewter is gonna be 10. It's gonna be antimony, and it's gonna be copper. Stainless steel is gonna be 70% iron, 18 to 20% chromium, 2 to 12%. And then a lot of times, depending on how strong they want to make that stainless steel, they'll add a little bit of some other metals or some other elements. Usually to strengthen iron, they're using the carbon to strengthen iron. And I'll put that on as extra credit. The same one. So sterling silver is 92.5% silver and 7.5% copper. Okay. So this is a summary of the nomenclature. So you guys should be able to look at this table and get everything you need to know. I should have what? I gave you guys a whole page.
Just that one.
Because it's tiny.
Yeah, Larry.
Goodness gracious.
Larry, I'll print it out for you. So, are you guys ready for the competition?
Brains.
Excellent. What was that? You said your brain is fried. Well, it'll give you an opportunity to relax a little bit till it's your turn to compete, right? So we left off on Jeremy. Let's see, online. Are you guys ready? You guys want to get your points back, right? Are you guys ready?
You have to help me. I'll help you.
All right, you ready?
That's all right.
Okay, so okay, so here is your.
Wait.
Okay, so online, let's see, who it's gonna be. Sorry. It's gonna be the champion. It's gonna be Tom. Okay, I think we're gonna have Jessica. Jessica, you're gonna come up. You ready to roll? Ready to take on Jeremy? Jeremy versus Jessica. Are you there, Jessica? What was that?
Okay, all right, cool. Who's next?
W for in person.
Let's say less, bro.
Let's see.
All right, come on, then.
Okay,
I
so
tried.
if not, Jessica's gonna be Joycelyn that's gonna be competing with Jeremy. Joycelyn, are you there?
No.
Yes. Yes, are you ready? But you're gonna try, right? Okay. Are you ready? Okay, so here is your chemical compound that I would like you guys to make.
I know.
There you go.
Right out.
Yeah. All teams go.
Oh.
We'll come back to you, Jessica, since you're there now. You didn't respond to me earlier, so I assumed that it was, so Joycelyn, it's Joycelyn's turn. But for the record, what you have is incorrect.
Alright.
Yeah.
Okay. Is that so? Yeah.
I might have spelled it wrong.
Get that?
Is that right?
That's right.
I thought they took off.
So it's Ethan.
That is correct. What goes to face to face?
Oh, what?
So face to face is up by 1.
Like, I looked away for a second.
You gotta like post a date. I'll be honest.
I don't know how to write.
Okay, so it's 3 to 4.
Alright, that's bro.
What was the answer?
What was that?
What was the answer again?
I don't know why I said
No,
that.
You're going fast, okay.
Okay,
It's time to go.
you guys ready for the next one? Okay, this time I'm gonna give you guys the acid, and you guys are gonna give me the chemical formula. You guys ready? And Jessica, you're up this time.
Thank you.
It would be Moy. Moy, you're up. You ready?
Let's go, big dog. How you doing? Oh, you don't have to put over there, bro.
Okay, the question is acetic acid. Acidic acid. Acetic acid.
I'm not doing it. I'm talking over that slide matter. Boy, you should please go up there to be you ready.
Acetic acid. Jessica, are you're there? It's acetic acid. Can you guys see my type?
Say it again. Go, 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 go. I told you, man, you gotta run, man. Do it. Come on. Come on. Yeah. This is big, too. I'm in.
That is incorrect.
Why I gotta do like that?
It's not written the correct way, so there's 2 reasons why it's incorrect. Okay, that's right. Jessica is correct. H C 2 H3 O2
I was right there with you, bro. I'm the trenches.
Okay, so remember, when we're talking about acids, we want to make sure that we're putting that H in front to represent that positive charge for one thing. You don't want to put it together, because if you Google it, it's gonna be wrong, because it puts everything together. That's how I know people cheat.
Go back.
Okay, good job. So online gets the point. So score is 4-4. We're back to 4-4.
Why?
Okay, are you ready? Are you ready? No, it's you. Get your way up there. Okay, so here is the name. Are you guys ready? And then I want you guys to give me the chemical formula.
You got this, don't even worry. Well, I mean, I got all.
I don't know who this was.
Huh?
Zero, why?
Okay, so that is your chemical name. Remember what I said about
The chart? Yeah, I know.
you remember?
Decent, bro, just rolls.
Now, wait a minute. So the person that should be paying attention should be over there with them, are you? You okay? Let's see. Oh, we got an answer. The answer is,
That's wrong. If we got the card.
is that correct?
No money on it, no money on it, no money on it. No, she changed it, you can't do that. Whoa.
What?
What the?
Okay. No, I actually didn't assign this. Liliana, are you there?
No.
It's yours. Liliana, it's yours. Okay, so can you give me the name of this compound?
No, she can't.
She's like, yes, she can.
Yes, yes.
I got you.
No, but you automatically disqualified.
Are you guys discussing it?
Yes.
Oh,
Okay. We'll talk about it after they try to give me an answer.
Yes.
Just kidding, we're here.
That is incorrect.
Yeah.
Oh, wait.
What you get?
Big O?
Oh, yeah, baby.
I'm getting a lot of answers here. Nope, that is incorrect.
Really?
Yeah.
Go.
Okay, give you guys one more attempt, both sides, and then I'll tell you what it is.
Good go. Good looks. And then negative at the top. Negative at the no, the full at the bottom. Damn.
Negative on top.
Negative
Yeah,
on
so
top.
you're
One
on
on
the negative.
Right. Yes, and then. Yeah, that works.
That is incorrect.
Yes. Take off the score.
Okay. So let me help you guys out. So what did we say about the Euclidean? The Y. What charge is at Y? I said it earlier. I did say it earlier. That's right. It is a +3 charge. So Y is a +3 charge. Okay. Hold on. Just relax. Hold on. We're gonna work through it, right? So since we know that the Y is a +3 charge. Now, polonium. Polonium is in which group?
Sulfur, group 16.
It's in group 16. So we know that if it's polonate, that means how many oxygen should be with that polonium? 3? Nope.
4.
4. So it should be PO, capital O, 4. So big, it's like poo. Okay. And then we know that it has a -2 charge, right? So then we can do the cross multiply. So we end up with Y2. You want?
No, I'm saying.
Yeah, don't listen to him. It's P O04. Yes, that's right. Parentheses 3.
Okay, so the 8 at the end.
Hey, we got it first.
Equals 0, 4,
That's
2.
right. Yeah, -2 charge. In the case for polonium, right? Because it's in group 16. So you want to look at the element that is like the polonium, right?
So the
Who's in the
charge
same group.
depends on which group it's in.
That's right.
But
And-
the 4 is the 8.
That's right.
Okay.
Dr. Henry.
Yes.
So for like Y for, how do you say that element? Yttrium?
Can you repeat that one more time?
How do you say the element name? The Y?
It's yttrium.
Yttrium. Okay, Y for that one, because it's so close to the noble gas, you use that charge?
Yeah, it's a special case. Earlier, I listed out the special cases. Why? The special case. That was always going to be +3.
Okay.
Can you write them out again? Yes, I can write them out again. The special cases. Okay.
So that means that this is a tie.
So, what was that? If it wasn't, you want to go again?
It was a tie, yeah.
Okay, you want to try it again? Okay, give me 1 second.
I trust all of them.
So yttrium is always going to be Y, and it's +3. I don't know why it does that. Okay, so cadmium.
You got your glasses.
That's going to be CD. That's going to be +1. Silver. That's going to be AG. +1. We have zinc. That's going to be ZN. 2+. And we have aluminum. Yep. It's going to be AL 3+. Okay, Marcos, are you ready?
Tell them I found more.
Okay, Marcos, they're talking mess already. Are you ready? Okay. Okay, you guys ready? Okay, so we're gonna do Okay, so here is the name of the compound. Very bottom, and up top. Did everybody get, oh, everybody got the charges these down? Did you get that down? Take a picture? I'll write it down for you. Okay. I'll put it on another page. Nitrous acid. Nitrous acid. Got it, Marcos? You see it? The lights just dim, or was it me? Yeah, it might be. It won't be the first time.
Face hands go like that.
Team online? You guys have an answer?
I hope I'm not wrong.
Not wrong, right?
You
You got it right.
Nope. You have an answer here. And that answer is,
Incorrect.
no, actually theirs is correct. Because it wasn't the right person that put it up. The right person needs to put it up. Marcos, one of the answers is correct because there's two different answers that are out there. No?
That's not it.
Yes.
Oh, so that's close.
Yes.
I was just.
The answer is HNOAQ. Okay, so let's look at it. So we have nitrate, which is NO3. NO3 minus. We have nitrite. Which is NO2 minus. And then we have hyponitrite. Which is NO minus. Now we know that we just need one H plus to balance that out, so it's H. NO. AQ. And we call it a day. Okay, and then that's hyponitrous acid. You have a question? Nitrite. All right. It's NO, yes. Okay. It's hyponitrite. Yeah. And then when we put ITE, it becomes OUS. Okay. Okay, Jason, you ready? Yes, that means yes. Let's go. Okay. What was your? What did you say?
I said.
Are you telling me the order, right? I thought you said something else. I was like, what?
Nah.
Okay, you guys ready?
I'm got it. We got it. Got it. I'm leaving.
I gotta go, Mr.
Okay, I will see you. Yep.
Yeah.
Video. Mobidium 4. Mobidium 4. Mobidium 4 permanganate.
Oh, got it, okay.
Damn. Yes, please.
And let's see, Mitzi, it's you. I'm sorry. Are you there, Mitzi?
Yes, I'm here.
Did I miss the DE?
Yeah.
Yes, I did miss the DE. There we go. Sorry about that.
I was like, yeah, no.
That is correct. Okay, we're down to, there's 2 more. I believe we are at a tie.
Yes.
Right, so we're at a tie. Okay, well, right now we're at a tie. We got 2 more. Are you ready? You gonna break the tie? Okay,
Answer.
the answer was MO.
I just want the record to show I wrote it before he said it to you, all right? No, I'm just kidding.
Yeah, but yours
Yes,
is
you did.
Oh, it's 3?
right. ITE, right?
Okay, you good, we got it. Well, she got it.
You said permanganate?
It's
Oh,
permanganate.
I didn't see the IT. I'm tired. I'm sorry. I failed D team.
Okay, guys, ready? It's, is it Ryle? Are you there, Ryle? Okay, good.
No.
Okay, so you're next. Are you ready? Okay. Let's see. This one is going to be. Sorry. Trying to make a dot. That's a dot.
That's a dot.
That's a dot.
Oh, okay.
Oh.
Application dot.
I'll see you guys. Drive safely.
Is that 11?
Yes.
Ah, you're sure, yeah, you're for sure, cameraman. You're for sure, cameraman.
Okay.
Wait, 11? I don't think we went over.
We did.
Yes, you did. Back up on that one there.
So wait, I forgot the 11. What's 11?
You're not asking me, are you? You're asking your teammates?
I'll type it in the chat.
Hey, what is it, man?
Okay, we have an answer. It's
Damn, that's no fair. We didn't write it out.
Palladium.
Hey,
Three.
there, that's no fair.
Oh,
Let's shoot that up.
that is incorrect.
Oh, yeah, never mind. That's wrong, man. Don't even worry about it.
Check it out, check it out.
What? Check it. Say less.
That is correct.
Let's
go. Okay.
Okay.
Okay, so face to face, take the lead by 1. So the correct answer is
Olivia, I thought it was lead.
PD, not PV.
Oh,
Oh my God.
Hydroxide. Because remember, no Greek prefixes in the ionic compound. Use the Greek prefixes in the hydrates and so it's un deca hydrates. Yes, remember, deca is 10, un deca is 1, dodeca is 2, 12. Un deca is 10, deca is 10, un deca is 11, dodeca is 12, trideca is 13. Okay, Stephanie, are you ready?
Yeah.
Okay, so this, you can come back, you can bring it back to a tie. And then we'll have to rely on Yolanda at the end. Okay, are you ready? Let's see. This is gonna be your, oh yeah, I know.
De verdad, pues todos los hombres son iguales. Como right. En vez de ser con un hombre que conoces que uno por conocer.
Okay, that is your compound. If you guys type out the element.
Yeah. Okay. Okay.
All right.
Where have you been?
You guys ready?
Where have you been, dude? Been struggling this whole time. What in the heck is going on, bro? Bro, where have you
Okay, we
been?
have a correct answer.
Where have you been, dude? You've been struggling. That's good.
Oh, so close. So the answer is,
Bro, where have you been, dog?
Yeah.
I had a bone pick with you, homie. I had a bone pick with you.
you. Silent but deadly.
I guess just want to go home. That's what happens. Is that CD, right?
C, what was that?
It's CD?
CO.
Sorry.
And 5. Okay, so that would be the correct answer. So the winners are face to face. I didn't get your guys' name.
Apparently.
Good try online. You guys did a really good job.
Man, you need to like move over yonder, bro. You like on the like, you go come to the suburbs, alright?
Did you say the suburbs?
Come to the suburbs. You need to come to that. You need to come to the north side. You're on the south side right now.
I put 10.
Everybody see it. Make sure you sign your name on here so you get your points. Nice try, everyone. So reminder, your practice exam is going to be going out tonight at 11:59 p.m. So most of you guys will see it in the morning. Practice exam. Your exam is going to cover chapters 2, 3, 5, 11, 12, 13, and let's see.
Ew.
There's
We're gonna be on a plane chilling.
a little bit of 15, a little bit of 8.
He said all of it.
Yeah.
The whole book. The whole book. It's the final.
Yes, the homework is he said to, I'm gonna put it till Sunday night, although right now it's till Saturday night.
So the homework you did?
Yes.
Okay.